Alrighty, so now we've got all of our training image file names. Remember, these are just file names at the moment, or file paths, probably the better way to do it. I've called this file name, so we'll just leave that there. So these are file paths to our training images, which means later on we'll have a way to access them. So it's important to note here that these are just strings. They're not the actual images just yet. We'll do that in a second. But what we're doing now is we need to get our labels ready. So these are our labels. We've just dealt with the file IDs and turned them into file paths. But let's now get our labels. So remember, the premise of machine learning is to turn our data into numbers. More specifically, when we're working with TensorFlow, it's to turn it into tensors. That's what we're moving towards in this little subsection at the moment. We'll write a little bit of text here. Since we've now got our training image file paths in a list, let's prepare our labels. Okay, we've got all our labels in labels CSV. Let's just have a look at them actually. Let's go labels, let's just create a variable called labels CSV breed. Keep it simple, you know. What does this come out as? Okay, so that's D-type object. Remember, we have to start turning these into numbers. So we might turn them into a NumPy array. So import NumPy as, now I wonder if I could just do this. Otherwise, I know another way to do it. And what if we go labels? Wonderful. How many are in there? Len labels. 10,222, which is amazing. The other way I was going to do it is if we comment out this. I'm doing command /. That's how you can comment out a whole line. And then we go to NumPy. Nice simple method in pandas. Same thing. Does same thing as above. Little trick there. Let's do the same thing as before. Compare the amount of labels to the number of file names. If we come back to here, after we've downloaded this and unzipped it into our Colab notebook, what we're doing here is by comparing the number of labels to the number of file names, checking for missing data. So if you remember back in the previous projects with structured data, there were some cells in the data frame that were missing. But checking it with unstructured data, if there's missing data, is a bit harder. So this is kind of the workaround we're doing. Check if number of labels matches the number of file names. And we're just going to do the exact same as before. So if len labels, so the length of labels, what we just did there, equals len file names, because what we're eventually going to have to do is pair up these labels with these file names, like what we've just done here. So index 9000 is Tibetan Mastiff, and its file name 9000 is this absolute lion of a dog. So let's go here, we'll print out a little confirmation for ourselves. Number of labels matches number of file names. Beautiful. Else print number of labels does not match number of file names. Check data directories. Fingers crossed. Beautiful. That's what we're after. Number of labels matches number of file names. Okay. Now, finally, since a machine, well, not really finally, we've still got a lot to go with this project. Since a machine learning model can't take strings as input, this is what labels currently is, right? It's an array of strings. What we have to do is convert it into numbers. How might we do this? Well, to begin, let's find a list of all the unique dog breeds. So there's 10,222 in here, but how would we find the unique labels? So let's do this. Find the unique label values. So I want you to have a little think about this. If you have a NumPy array, I've given you a little hint. How might you find the unique values in a given array using NumPy? Did you have a little think? You could even look it up. There's a good Google search for that. So NP unique is how we find the unique elements of an array. And now this is pretty cool with Colab, right? It just pops up this doc string without me even doing anything. So we want to find the unique labels. Let's find that. Unique breeds. Let's have a look at that. Awesome. So there's a whole bunch of different dog breeds. So let's have a look at them. Brittany Spaniel. I never even heard of that. Chihuahua. Gordon Setter. Great Dane. Yeah, there's a beast. Okay. Getting distracted by dogs. And so this should be 120. Wonderful. So that is because we have 120 breeds of dogs. We're lining up here, right? We're getting our data ready. We're getting it prepared to get into tensors. We've only got 2 arrays of strings. How might we turn these into numbers? Why don't we turn it into an array of booleans? Let me give you an example rather than talk about it. So turn a single label into an array of booleans. So print label 0. We'll just use label 0 as an example. So label 0. Now we're going to use the comparison operator to compare the first label to unique breeds. And what this should return is an array of true and false values where everywhere in unique breeds, label 0 doesn't equal, it should be false, but the only location where it does equal should be true. There we go. Let's have a look at these. So it's a Boston Bull, but then if we have a look at unique breeds, so we can see true is here. So what's that, about 12 in? So if we go through here, count them up. If you counted them up, you'd find Boston Bull. There we go, true. That's what we're after. Let's do that for every single label. So turn every label into a Boolean array. If you're looking at this and this is just all trues and falses, you're probably wondering how is this going to be converted to numbers, but we'll see in a second. There's a special thing with NumPy arrays and Boolean values. So let's go Boolean labels equals label. We'll do another list comprehension here. So label equals unique breeds for label in labels. Whew. Let's see what the code says first, then we'll talk through it. If in doubt, run the code. Wonderful. And Boolean labels should be 10,000 long, or 10,222, whatever it was. Wonderful. So that means we've turned every single label into a Boolean label. Now, what is this little list comprehension doing? All it's doing is a scaled up version of what we've got here. So it's saying, do this little one-off example for every label in labels. And if we remember, then labels is 10,222 because we have 10,222 labels. So it's done it for every single label. You might be thinking again, why are we turning them into true and false? Well, how we can convert these Boolean arrays into numbers. More specifically, one-hot encoded numbers. So, if in doubt, run the code. Let's check out the code, then we'll talk it through. So, example, turning Boolean array into integers. Print label 0, we'll get the first one. So, this is the original label, straight from the data frame, straight from label CSV. Print np where unique breeds equals labels 0. Print. So actually, we should probably tell. This is the index where label occurs. And then we're going to go print Boolean labels 0.argmax. So this is index where label occurs in Boolean array. And then we're going to go print Boolean labels as type int. So there will be a 1, or there should be a 1 where the sample label occurs. Whew, that's a big cell, but we're going to check it out. Look at that. So the original label is Boston Bull, and it appears at the 19th index, which is the same in our Boolean labels 0th index, so it appears at 19. And if we were to count this, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 is where 1 occurs. So now, every single label in Boolean labels is actually in this type of format. So there's a 1 where the actual label occurs. So if we did the same thing for, let's go 2, and then print labels 2, is Pekingese occurs right down here, and 0 for everything else. Wonderful. So now we've got our labels in a numeric format, and our image file paths are easily accessible because remember we've got file names. These are our image paths. They aren't numeric yet, but we can do that later on using TensorFlow. So now we've got our data in an accessible format. Let's create some training and validation sets, because if we come to our files, we notice when we download it from Kaggle, we only have a train and test set. To do our experiments, we want to split our data into training and validation. So that's what we'll do in the next video.